Day 13 of 90. Today we are building Python patterns for working with REST APIs in security tooling. If you write security scripts that talk to threat intel feeds, CIEMs, or cloud provider APIs, this is foundational. Every pattern I show today comes from production security work, not textbook examples. Let us get into it. First up, secure authentication. The number one mistake in security scripting is hard-coding API keys directly in your code. I have reviewed hundreds of internal security scripts and at least a third of them have plaintext keys sitting in the source. Here is a better pattern. We build a secure API client class that pulls the bearer token from an environment variable. It uses a request session object so we get connection pooling and consistent headers across every call. We set a custom user agent because many APIs throttle or block the default Python requests agent. The session also gets a default timeout of 15 seconds so we never hang indefinitely waiting for a response. This is a small class but it eliminates an entire category of credential leakage. Second pattern, API key rotation. For long-running security daemons like a continuous threat monitor, keys expire and get rotated. You do not want to restart your service every time that happens. I built a rotating key manager that reads keys from a JSON secrets file and caches them in memory. It checks the file age against a configurable refresh interval, typically 1 hour. When the interval passes, it reloads from disk. In production you set the secrets file to 0600 permissions and run the daemon under a dedicated service account. This means your ops team can rotate keys by updating one file and the service picks up the new key within the refresh window. No restart, no downtime. Third, paginated retrieval. Security APIs return large datasets. A Shodan search or virus total domain lookup can yield thousands of records. You cannot just call the endpoint once and expect everything. We need a pagination loop. The pattern walks through pages using an offset or cursor parameter, collects results into a list, and stops when a page returns empty. Critically, I add a max_pages safety cap. Without it, a misconfigured query against a feed that never stops returning data will loop forever, burning your entire API quota. I typically set the cap to 50 pages and log a warning if we hit it. That is enough for most security queries and protects against runaway consumption. Fourth, rate limit handling. Every security API enforces rate limits. VirusTotal gives you 4 requests per minute on the free tier. Abuse IPDB caps at 1000 per day. Getting temporarily blocked during an active incident is the absolute worst time to discover your script does not handle 429 responses. The pattern is straightforward. When we get a 429 status code, we read the Retry-After header and sleep for exactly that duration. We also monitor the X-rate limit remaining header proactively. If remaining calls drop below 5, we log a warning so the operator knows they are approaching the limit before they hit it. 3 retries maximum, then we raise an exception rather than looping forever. Fifth, resilient error handling. API failures during an incident can be catastrophic. The network drops, the upstream service goes down, you get an unexpected HTML error page instead of JSON. Our resilient caller catches each failure type separately so the log tells you exactly what went wrong. Timeout, connection error, HTTP error, JSON decode error. Each gets a specific log message. The key addition is the fallback parameter. You pass in cached data, maybe yesterday's IOC list, and if the live API fails, you keep working with stale data rather than having nothing. Stale threat intel is better than no threat intel when you are mid-incident. That is day 13. 5 production patterns for REST API security automation, secure auth, key rotation, pagination, rate limiting, and resilient error handling. These are not theoretical exercises. Every one of these patterns comes from real incidents where the API layer was the point of failure. Get this plumbing right and your security tooling works when it actually matters. Tomorrow on day 14 we will combine these into a unified threat intelligence enrichment pipeline that pulls from multiple sources simultaneously. Follow along and I will see you then.